Let's proceed further things. So we have understood that in the scientific notation consists of what? The base, the coefficient and the exponent. Okay, if there is a standard form, for example 3.1 is written, or let's suppose it is 3100 is written, and I want to write it in the scientific notation, then I have no decimal over here. It means it is at the end. When I write the scientific notation, I need to move it to the left side. When I move to the left side, I put the positive power and 3.100. Then I said after the in the end there is no need to write the 0. Okay, then write 10 to the power of. Since we are moving to the left, in the scientific notation we write the positive power. So how many places we have moved? 3 places. So we will write 10 power 3. But the question is same, and we will have, let's suppose 5.00003, okay, and here 0.000, okay. So it is like here, okay, 0.0005 and 3. This is my question, and I want to write in the scientific notation, means I have to move to the right. When I move to the right, my power will be negative, and I have to move up till the first digit. The first digit should be between 1 and 10. Cannot be 10. 1, 2, 3. So we are moving 3 places. So we will write 5.3 and then 10 to the power of minus. Since we are moving to the 3 places, so we will write here negative 3. This is what we have understood so far. The other thing what we understood, that if already the scientific notation is written, then if the power is positive in the scientific notation, to write in the standard form, I will move to the right side. I will move my decimal to the right side. So I am moving. I am writing here 2.3 and I have to look here. What is the exponent? The exponent is 5, which means I have to move the decimal 5 places towards the right. So 1, 2, 3, 4 and 5. And at the empty places, I have to just fill it by writing the zeros. So now no need to write here the point. So the final answer will be 2, 3 and 1, 2, 3, 4. Now, for example, if I have 9.8 and 10 to the power of minus 4. So in that case, what I will do? I will move towards the left side. When in the scientific notation the power is negative, I have to move to the left side. How I will write? First I will write 9.8. Let's move 4 places to the left. So 1, 2, 3, 4. So the point comes over here. So fill up the empty places with the zeros, and before the decimal always write the 0. Now what is the final answer? 0.00098. Other thing I explained, that if I have 5.3 10 to the power of 4 and I have 2.9 10 to the power of 6. Okay, so first see where is my decimal. My decimal in both the cases is after the first digit. Then I will check what is the power of the 10 or exponent of the 10, and the greater is the 6. So 2.9 into 10 to the power of 6 is bigger than 5.3 into 10 to the power of 5. No need to solve. Just try to find out the answer. Now here they are asking you that we have a ratio and you have to compare that ratio. Okay, so look at the ratio. It is 3.45 into 10 to the power of minus 8 divided by 3.45 into 10 to the power of minus 11. Let me write here for you. Okay, so we will write here 3.45 into 10 to the power of minus 8 divided by 3.45 into 10 to the power of minus 11. So what have you seen that 3.45 and 3.45 they are same. So 3.45 times 1 gives you 3.45. So you can cancel out. Now compare only the factor which has a power. Now in the previous lesson we have already studied that if the bases are same and they are written in the form of ratio, we will apply the quotient property. So we will write the base one time. We write the first power as it is, and for the second power we change the sign. So what do you get? 11 minus 8 gives us 3. And what is 10 to the power of 3 means? It means 3 zeros. After the first digit there should be 3 zeros. Okay, now let's give the answer. First compare the powers of 10. So 10 power negative 8 divided by 10 power negative 11 gives us 10 power 3, which means 1000. Now compare the first factor. First factor for the above one is 3.45 and this also 3.45. So when you cancel them, what you will get? Of course 1. Now, how many times 3.45 is greater? 3.45 is 1 into 1000, right? Which means it is 1000 times greater than 3.45 into 10 to the power of negative 11. Okay, now Next, I will say that you find yourself. Okay, write the answer in the comment box. It's so easy. So better to write or pause the video and check if you can solve the question. So use a ratio to compare 4.8 into 10 to the power of 9 and 12. Okay, and then after the 12 we have 3 and 3 6 zeros. Okay, so write this in the scientific notation. So 1 2 1 2 3 4 5 6. How in the scientific notation you will write? There is a point over here. Move to the left. When we move to the left, what we will do? We write the negative power. 2, 3, 4, 5, 6 and 7 places. So 7 places moving, that's in the scientific notation. Moving towards the left means negative power. So negative power 7 places. And what you will write? 1.2 and then we have 1.2. So we will have 1.2 into 10 to the power of minus 7. Now check if I am correct or I am wrong. So let's see what is the mistake. Yes, when we move to the left, power should be positive. Why? Because we are not doing the scientific, we are writing the scientific notation, right? So, of course, now try, we are doing the scientific notation, it means the process should be changed. Okay, so now here we will write 10 to the power of positive 7. Now how to solve it? 10 to the power of 9 as it is, change the sign of the 7. So you will write minus 7. You will get 10 to the power of 2. What is the first digit? The first digit of the second one is 1.2. Remember 4.8, okay, divided by 1.2. Okay, so if you see 12, okay, let's suppose there is no decimal right now. I'm not teaching you right now how to eliminate the decimals, but let's suppose the decimals are not there, because if you move the decimal over here, so it becomes 480. If you move the decimal over here, it becomes 120, and the zeros are cancelled out. And we know that 12 times 1, 12, and 12 times 4 is 48. So answer is 4. So the answer is 4. Okay, so we can say 4 into 10 to the power of 9 minus 7 is 2. So 10 to the power of 2 means what? 4. And after the 4, how many zeros you have to put? 2 zeros. So it is 400 times greater than the other digit. Okay, now try to solve yourself the D part, because until you won't practice yourself, you won't be succeeded. I am going and moving to the next kind of the question. Here is the question. The question states that a geologist is comparing the two rock samples. Sample A has a mass of 0.0015 and sample B has the mass shown on scale. Okay, in your textbook there is a scale in which a rock is lying, and on the scale it is written 750.0. This is the scale as shown in your textbook. Okay, so write down both masses in the scientific notation. So look at the sample A and while writing in the scientific notation, when we move to the right, the exponent will be negative. How many places? Between the after the first digit. Okay, so let's see 1, 2 and 3. So we will write 1.5 into 10 to the power of 3 places, it means negative 3. So this is our sample A. What about our sample B? So our sample B is 750 grams, which means we have to move to the left. Okay, so after the first digit, we have to put the decimal, which means we are moving 2 places. So it will be 7.5. Now, after the 5, we don't write 0 in the end. Into 10 to the power of 2. Why positive 2? Because we are moving to the left side. Okay, now how many times the mass of sample B is greater than sample A? Okay, so simple. What you do, you take the ratio of the sample B with sample A, because the B is greater. Okay, so we write 7.5 into 10 power 2 on the top and 1.5 into 10 power negative 3 in the bottom. Look at this now. Now here 75 and here 50. Okay, I am showing you here 75 and here 50 and here point, right? So after the decimal, okay, move the decimal to the right. So it becomes 750. Here also move to the right, it becomes 150. So it cancelled out. So what we will get? We get 75 divided by 50. Now read the times table of 15, and we know that 15 times 5 gives us 75. So this is 5. So I will write here 5. Now 10 power 2 on the top, and if the bases are alike, we write the base one time. The upper power we write as it is, and for the below power we change the sign. So it will be 5 into 10 to the power of 5. Now 5 means after the 5 put this 50. So 1, 2, 3, 4 and 5. So I hope that this is clear to you. This is the last example. Because the other examples are almost same, you can work on it, but here it is a little bit let's make a practice. So here determine which number is greater. Okay, so here look at this. This is 7. Okay, so 7 can be written as 7.0 and this is 3.5, so it can be written as 3.5. Now we know 7 is greater than 3.5, right? But let's try to find out what is the powers in terms of 10. Okay, 10 to the power of 12 is greater or 10 to the power of 9 is greater? Of course, 10 to the power of 12 is greater. So you will write 7 into 10 to the power of 12 is greater than 3.5 into 10 to the power of 9. Now, how many times it is greater, right? So, what do? You take the ratio of the bigger with the smallest. So, big one is 7, okay, times 10 to the power of 12 and the smaller is 10 to the power of 9. Now, look at this. You know 35 times 2 gives you 70, right? So, it gives you 2. Now 10 power 12. Look at this one. So we will write 10 to the power of 12 as it is. 10 to the power of 9 is in the denominator. So change the sign. This will give you 12 minus 9, 10, 11, 12. It will gives you 3. So it will gives us 2 times 10 to the power of 3. Right? So now after the 2, how many zeros you will put? 3 zeros, of course. So it is 202,000 times greater. Let's try other one. So 1.4, here 2.8. Now we know 2.8 is bigger. Okay, now check the powers. 10 power minus 5 is bigger or 10 power minus 4 is bigger. Of course, 10 power minus 4 is bigger. The negative power, remember, 4 is smaller than 5, right? But minus 4 is bigger than minus 5. Remember this thing. Because negative number is smaller than negative number, this will be greater than the greater negative number. Okay, so which one is the bigger one? The bigger one is this one, 10 power negative 4. So write it on the top. So we will write 2.8 into 10 to the power of negative 4. And in the denominator, we will write 1.4 into 10 to the power of minus 5. Now, as I told you, the times tables are very important because 14 times 1, 14 and 14 times 2, 28. So, we will get 2. Now, 10 to the power of. The upper one is minus 4. We write it as it is. Then for the below one, we always change the sign. So, it becomes positive 5. So 2 into 10 to the power of. So 5 minus 4 gives us 1. It means 10 has 1 power. So after the 2, there will be only 1 0. So this is 20 times greater. Let's do last one. So 16,000. Write it in the scientific notation, which means that decimal is here. Move to the left. Moving to the left gives us positive power. Okay, how many times? 1, 2, 3 and 4. So 1.6 into 10 to the power of 4. Compare it with 1.6 into 10 to the power of 8. So of course 1.6 and 1.6 are same, but the power of this is bigger than the power of that. So let's compare. So the bigger one goes on the top and the smaller one goes at the bottom. Now 1.6 cancel out. Now 8, here we have 1 because 1.6 times 1 divided by 1.6 gives us 1. 10 to the power of. Now we write the upper power as it is. For the below power we just change the sign. So we will get 10 to the power of 4. 8 minus 4 gives us 4. Which means after the 1, how many zeros I have to put? 4 zeros. So that would be my answer. I hope that you understood the whole concept. If some of the questions I didn't explain it, it means that they are repeating and they have the same idea. Now always, as I say again and again, that in order to understand maths needs a lot of practice. So see you in the next video. Bye bye.